As we continue, we're going to spend a bit of time and look at how the three main printer methods work. FDM utilizes a filament, which typically comes in a large roll, is forced through a heated nozzle. As the nozzle moves, it lays down layers. Typically, the slicing software will have these layers crosshatched to increase the strength. PolyJet machines tend to contain at least two print heads, one for model and one for support, and both are printed as they go along, and a UV lamp follows to cure or harden the printed model. As the print head moves from side to side, a roller also follows it, which helps keep the surface smooth and level. This is similar to a burnishing process in typical manufacturing. With each layer, the build platform will lower down. With SLA, the laser will sinter the metal floating in the suspended solution, and then again, the tray will lower down one slice height, and the laser will again go over and sinter the metal that's free floating, and this will continue until the final part shape is achieved. This chart compares the three most common technologies, FDM, SLA, and SLS, with respect to resolution, accuracy, surface finish, throughput, complex design, and ease of use. The FDM process tends to be fast, has a low consumer cost for the machines and materials. The con of it is that it has low accuracy, low detail, and limited design capability depending on your printer. Its typical applications are low-cost rapid prototypes, basic proof of concept models. SLA has a great value, high accuracy, smooth surface finish, and a range of functional applications. On the con side, it's sensitive to long exposure to UV light. This will cause your parts to break down over time. And its typical applications include functional prototyping, making of patterns, molds, and tooling, many dental and jewelry applications, as well as casting and model. The SLS process will produce strong functional parts with great design freedom and little need for support structures. Unfortunately, it also has a rough surface finish and there are limited material options. It's typically used for functional prototyping, short run, bridge, or custom manufacturing. Shown here are the typical print volumes, materials, and training required, although this is changing constantly. With respect to your facility, FDMs always function better in a climate-controlled or air-conditioned environment, and it's preferable to have ventilation with them. The SLA are suitable for any office environment, and the SLS require a workshop environment with reasonable space for the larger machines. Other equipment will be required for removal of support, curing of the various media types, and all post-processing.